The James Webb Telescope has basically uncovered the most clear image of Proxima B in history, uncovering staggering pieces of information into a potentially reasonable exoplanet. It obliges us as we set out on a journey through space to uncover the insider facts of Proxima B, and see if it very well may be the following Earth. We should take off into the immense span of room where a strange planet exists in the tenable zone of its star Proxima Centauri. This planet isn't simply any standard stone, it's genuine. C. Proxima B is found a simple 4.2 light-years from us. This planet is shrouded in secrets and marvels. Might it at any point be one more Earth with oceans and life blooming on its surface? At any rate, stand by, there's more. Proxima Centauri B isn't the only one in that frame of mind around the red small star. It has a buddy, Proxima Centauri C, and who can say for sure what different secrets the star framework holds? Perhaps there's another sidekick that we haven't yet found. The mystery doesn't stop there. Proxima Centauri delivers generally similar measure of energy from its star as Earth does from the Sun. Might this really intend that there's water on its surface and maybe even life? As we at some point investigate past our own nearby planet group, we experience an altogether new universe of exoplanets, planets that circle stars other than the Sun. With 200 billion stars in the universe, the open doors for exoplanets are unending. Some exoplanets even need meander uninhibitedly, untethered to any star, like meandering explorers in space. Among them all, Proxima Centauri B stands apart as a particularly hitting and spellbinding planet with a year that endures just 112 Earth days and a separation from stars for the most part nearer than Earth is to the Sun. For sure, one side of the planet is continually washed in daylight, while the contrary side remaining parts in never-ending haziness. Presently we should analyze Proxima Centauri, the star that Proxima B circles. Proxima Centauri is important for the Alpha Centauri triple star framework. This framework incorporates RIL, otherwise called Alpha Centauri, and an Alpha Centauri B. Together these stars structure the nearest star framework to our nearby planet group. The two stars RIL and Alpha Centauri B structure a parallel framework known as Alpha Centauri N and B. These G and Kuiper stars show up as one star in the group of star Centaurus and are the third most brilliant stars in our night sky, with a pinnacle iridescence of under 2.7. Proxima Centauri, additionally called Alpha Centauri C, is a red diminutive person or M-sort star found 21 light-years from the other two stars, normally multiple times the distance among Earth and the Sun. It is the nearest star to us. Proxima, truth be told, implies the nearest star in Latin, and it was found in 1915 by Scottish stargazer Robert Thorburn. In spite of being our nearest heavenly neighbor, it isn't noticeable able to the unaided eye, having an obvious extent of 11.13, which is much fainter than the human EY's restriction of 6.5. In any case, don't let that fool you. Proxima Centauri is as yet a star worth concentrating on. Red diminutive people like Proxima Centauri are among the most effective as far as energy creation. They may not create a ton of energy, but rather the inward convection processes at their centers keep them sparkling for trillions of years. As a rule, Centauri will stay a fundamental succession star for one more 4 trillion years. Anyway, the tenability of a red small star like Proxima Centauri is as yet bantered. For one, it's a flare star, meaning it has continuous and serious blasts. As a low-mass star, its livable zone would be a lot nearer to it than the Sun's, projected to be someplace in the scope of 0.23 to 54 pennies, yet it's not quite so tenable as it appears. Proxima B is besieged by extraordinary bright radiation from its star Reg L, more grounded than the radiation we get from our Sun. That is correct, its limit to such an extent that even the lightest particles of hydrogen are stripped away alongside nitrogen and oxygen. Yet that is not all. On the grounds that a planet is at the right separation from its star doesn't mean it can uphold life. Proxima B might not have a steady air, which is fundamental for directing temperature and keeping a water-accommodating surface. Without it, residing animals would be defenseless against unforgiving space weather patterns, making life almost unthinkable. So while Proxima B could seem Earth-like on a superficial level, it is a long way from having the option to help. Life researchers remain fairly wary, as there are many elements that render it unfriendly. The mission to uncover reality with regards to Proxima B proceeds. Some actually hold trust. One device that has earned the consideration of stargazers is the James Webb Telescope. Following quite a while of expectation, the telescope was at last sent off in 2021 and will assist us with deciding whether there is life on Proxima B. Anyway, likewise with everything in science, things are never essentially as clear as they appear to be. A few changes were expected to guarantee the James Webb Telescope conveys precise pictures. As Abby Tabor, a hypothetical physicist at Harvard, makes sense of assuming that a planet like Proxima B can retain light from its star, it can likewise produce it as infrared light. The James Webb Telescope was explicitly intended to identify infrared light and can catch pictures of this light from the planet's surface and quest for designs that could affirm the presence of water or an air. Yet imagine a scenario where the planet has an air that is not helpful for life. The presence of an environment doesn't ensure the presence of life. Alerts Ed Turner, an astrophysicist at Princeton College. Proxima B could be like Venus, with a thick air that is fundamentally denser than Earth's and outrageous temperatures that would make it unimaginable for life to exist. The excursion to unwind the secrets of Proxima B is not without its difficulties. While the James Webb Telescope holds promise, there are different elements to consider. With costs mounting, space researchers are feeling the pressure to track down ways of noticing planets like Proxima B. Much is in question, but the rewards are much greater. The chance to investigate the unknown, to reveal the mysteries of a distant planet that holds the potential for life, is a pursuit worth pursuing. If the exoplanet were livable, could we one day visit? It's the nearest exoplanet to us which makes it so enticing, essentially like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could, indeed, have conditions suitable for life. Proxima B's proximity also makes it an ideal objective for our quest for life beyond Earth. With it being so close, it's a great contender for interstellar missions. Imagine exploring this Earth-like exoplanet. Despite the fact that we can't yet go there, it's certainly on the radar for future missions. As technology progresses, it's perhaps one of the most thrilling endeavors in the field of space exploration. However, it's no easy task. It would require 75,000 years for spacecraft like Explorer 2 to reach the Proxima Centauri system. Nonetheless, a solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system and Proxima along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. And here's something even cooler. This cutting-edge technology could offer insights into the possibility of life on other planets like Proxima B. However, like anything ambitious, there are limitations. For example, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B could be like Venus, with a thick, hot atmosphere that is unfriendly. Moreover, get this, the James Webb Telescope can detect such emissions, provided it reaches a brightness of just 5% of the daytime side. Now, 5% may not seem like much, but when dealing with a star that is generally dimmer than our own Sun, it's quite significant. If Proxima B has advanced civilizations, they might use bright orbital mirrors to reflect sunlight from the daytime side to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being huge gas giants while others resemble our own Earth. But what do we know about them? One type of exoplanet that has captured the attention of space researchers is the gas giant. These planets are similar in structure to Jupiter and Saturn, but much larger. Some of these behemoths have been dubbed super-Jupiters, surpassing even the largest planet in our solar system. But that's not all. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a scorching world with temperatures hot enough to melt metal. Imagine seeing such a planet up close, with its violent storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their climates being difficult to study from a distance. Let's not forget about Earth-like exoplanets, which resemble our own Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super-Earths, which have masses more than twice that of our planet but are lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth, with an estimated mass of 7 Earth masses. It orbits within the habitable zone of its host star, and researchers are currently investigating whether it could support life. Proxima Centauri b is particularly compelling because it is the closest potentially habitable planet to our solar system. As we continue to explore these fascinating worlds, The James Webb Telescope promises to provide even more insight into their potential for life and habitability. The appeal of Proxima Centauri B lies not only in its proximity but also in the enticing possibility that it might possess conditions conducive to life. As we probe further into the exoplanet's characteristics, the question on every researcher's mind is whether Proxima holds the keys to understanding whether life can exist beyond Earth. While it may be a harsh world, its orbital position within the habitable zone and its potential water presence make it an exciting target for future exploration. However, there's a catch. The proximity of Proxima Centauri B to its star means that it may be subject to dangerous radiation, especially given that red dwarf stars like Proxima Centauri are known for their violent flares. These flares, which emit intense bursts of radiation, could strip away a planet's atmosphere over time, making it difficult for life to thrive. Proxima B may also face tidal locking, a condition where one side of the planet is permanently facing the star while the other side remains in perpetual darkness. This could lead to extreme temperature differences between the two sides, complicating the conditions necessary to support life. Yet there are still many uncertainties. We don't fully understand how the planet's atmosphere interacts with its environment. For instance, could Proxima B have a protective magnetic field that could shield it from the star's radiation? This would be crucial for supporting life on the planet. Similarly, the possibility that life, if it exists on Proxima B, may have adapted to the harsh conditions cannot be ruled out. Life on Earth, after all, has managed to thrive in even the most extreme environments, from the depths of the ocean to the frozen tundra. Could Proxima B offer a different form of life, one that thrives despite challenges we can't yet imagine? Despite these considerations, Proxima B's proximity to Earth makes it an excellent candidate for interstellar travel, particularly with future advances in space technology. While our current spacecraft like Explorer 2 would take thousands of years to reach the system, more ambitious missions are being proposed. Solar sail technology, for example, offers a potential solution. Using the pressure applied by sunlight, solar sails could propel spacecraft to a significant fraction of the speed of light. This method could bring us closer to realizing the dream of sending probes to explore distant exoplanets like Proxima Centauri B. The prospect of one day sending humans to Proxima B is an even more enticing possibility. While this prospect remains distant, it captures our imagination and underscores the importance of continued exploration and research. For now, the James Webb Space Telescope will serve as our eyes into this distant world. It will monitor Proxima B's atmosphere, study its surface, and gather essential data to help us determine whether it can support life. Through its infrared capabilities, Webb can provide us with valuable insight into the planet's climate, composition, and more, bringing us closer to understanding whether Proxima B could one day be a second home for humanity. As we move forward, it's clear that exploring exoplanets like Proxima B offers more than just the chance to find alien life. It also represents our desire to understand the universe and our place within it. Every discovery, each piece of the puzzle, brings us one step closer to answering fundamental questions about life, the universe, and what lies ahead for humanity. Regardless of whether Proxima B turns out to be habitable, the journey of exploration will continue to inspire and shape our future.